reliable natural source of radiations. Or we say E equals sigma T to the power 4. This sigma is a constant called Stephen's constant. Fall on a material medium in fluids exclusively. Heat is transferred in fluids. Unlike conduction, their particles do not move, they simply vibrated. Heat energy was transferred. Hello students. In my previous session, we started discussing about modes of heat transfer, the three different ways through which heat is transferred from one body to another, from one region to another. And those three ways were conduction, convection, and radiations. We told conduction is a process of transfer of heat in solids, where exclusively in solids, from a region of higher temperature to a region of lower temperature without the actual motion of particles. We then spoke about temperature gradient and finally concluded saying that thermal conductivity. We shall proceed today with the other two types of heat transfer. Now, today we shall now discuss about convection of heat. Again, a type of transfer of heat which you should have studied in your lower class. It says it is a process of transfer of heat from one part of the fluid to another by the actual motion of particles. My dear students, we define convection as a process of transfer of heat in fluids exclusively. Heat is transferred in fluids through the process of convection, and this happens by the actual motion of particles. How actually this phenomenon takes place? Now, I have a beaker which is containing water. A container, a beaker which is filled with water. So we have a beaker that is filled with water, and heat is supplied to this beaker or the vessel. I'll put it in proper words. A vessel containing water to which heat is supplied. Now, the base of the vessel gets heated up. First, it is the base that is getting heated up through the process of conduction. because base is a solid, it is a vessel, and here the base of the vessel is getting heated up through the process of conduction. Now what happens once the base is getting heated up? Heat is transferred to the first layer of this fluid. From the heated region, transfer of heat happens to the first layer of the water, and this happens by convection. Here there is physical motion of the molecules. The molecules of the water, heated molecules, move to the first layer, heats it up. Next, from here, the particles move to the adjacent layer. Convection takes place. You call them as particle layers. Again, next subsequent layers of water. Thus, we see that water is getting heated up by the actual motion of the particles, and this is what we call convection. So we say it is a process of transfer of heat from one region of the fluid to another, where there is actual motion of the particles. Unlike conduction, their particles did not move, they simply vibrated. Heat energy was transferred. Here, there is actual motion of the particles, and we say liquids and gases are heated up through convection. Now, the next mode of heat transfer is something what we call radiations. A very common word, alva? Source of radiations. Sun is the most reliable natural source of radiations. Now, what is this radiation? Again, yes, it is a mode of transfer of heat. The process of transfer of heat without an intermediate medium is called radiations. It is a process of transfer of heat without any intermediate or in between medium. Radiations, here heat transfer takes place directly from the source to the receiver. There is no in-between medium, intermediate medium carrying this heat directly from the source to the receiver. Heat is transferred, and that is what is called radiations. So we say the process of transfer of heat without in-between mediums, intermediate mediums, is called radiations. Now, students, we will study the properties or features of thermal radiations, heat radiations, and this is always asked for 3 marks. in the examination, the properties of thermal radiations is asked for 3 marks. And it is exactly similar to the propagation of light. What are the features which gravitate the propagation of light is similar to the features of thermal radiations. Now, the first property says that they don't require a material medium for their propagation. Thermal radiations can also travel in vacuum, free space, exactly as light does. So, it does not require any material medium to move. That is what I am calling as propagation. Thermal radiations can propagate, can move in free space as well as vacuum. Second, they travel in vacuum with the speed of light. I told they don't require a material medium for their propagation. They can travel in vacuum. With what speed? Exactly the speed of light. What is the speed of light in vacuum? 3 into 10 power 8 meter per second. So the speed of thermal radiations in free space in vacuum is 3 into 10 power 8 meter per second. Given any medium, any material medium, free space or vacuum, they are reflected as well as refracted. Reflect. Light reflects when stopped by an obstacle. What is reflection? Coming back to the same incident medium, returning back to the same medium from which they travel. Take a soft rubber ball, hit it to the wall, it comes back to the same medium, reflection. So, given any medium, thermal radiations are reflected as well as refracted. Refraction means bending, change in the direction, change in the path. So we can say thermal radiations exhibit the phenomenon of reflection as well as refraction. Next, thermal radiations exhibit the phenomenon of interference, diffraction, and polarization. I don't talk much about this property. All these three phenomenons are distinct optical phenomenons. To understand this, we go to our 12th standard where you will have some tools of optics. Just now remember, thermal radiations, they exhibit the phenomenon of interference, something called diffraction, and something called polarization. Next one. When radiations are incident on a surface, heating effect is observed. Andre, when radiations fall on a material medium, the surface of the medium gets heated up. ಅದನ್ನೇ heating effect ಅಂತ ಕರಿತೀವಿ. Thermal radiations heat the surface of the medium on which they are incident. So heating effect is observed when radiations fall on the surface. And finally, they exhibit something called rectilinear propagation. Linear. The word linear means straight line. And the word rectum means medium. Greek word rectum is a medium, which means given any medium, light always travels in a straight line. That is called rectilinear propagation. So these are the different properties of thermal radiations. Quick to summarize, they don't require a material medium for their propagation. They can even travel in free space or vacuum. What is the speed with which they travel? They travel in vacuum with the speed of light. Beautiful. What is its magnitude? 3 into 10 power 8 meter per second. These thermal radiations are reflected as well as refracted. They exhibit the phenomenon of reflection as well as refraction. They exhibit interference, diffraction, polarization. They heat the surface on which they are incident. And they always travel in straight line given any material medium. Now, with respect to radiations, we study a very important law called as Stephen's law, something related to radiations. Carefully listen now. Stephen's law says the heat energy radiated from a surface. Radiated andre makla simple terms ali given out anta artha or coming out anta artha. Heat energy radiated from a surface of unit area. The surface should have unit area. Unit andre ಎಷ್ಟು 1 meter square area in unit second. Unit second andre 1 second. So the heat energy that comes out of a surface of area 1 meter square in 1 second is directly proportional to 4th power of absolute temperature. ಒಂದು ಯೂನಿಟ್ ಏರಿಯಾ ಇರುತ್ತೆ, 1 meter square area of a surface ಇರುತ್ತೆ. 1 ಸೆಕೆಂಡಲ್ಲಿ ಅದರಿಂದ ರೇಡಿಯೇಟ್ ಆಗ್ತಿರೋ ಎನರ್ಜಿ is directly proportional to 4th power of absolute temperature. So E is proportional to 4t to the power 4. T temperature, or we write E equals sigma T to the power 4, where this sigma is called Stephen's constant. It is a constant called Stephen's constant. So the heat energy that comes out of a surface area ಎಷ್ಟಿರಬೇಕು? 1 meter square area. ಟೈಮ್ ಇಂಟರ್ವಲ್ ಏನಾಗಿರಬೇಕು? 1 ಸೆಕೆಂಡ್ ಆಗಿರಬೇಕು. ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ವಾಟ್? 4th power of absolute temperature. Or we say E equals sigma T to the power 4. This sigma is a constant called Stephen's constant. And finally, we will write Kirchhoffs laws, which says ratio of emissivity to absorptivity. Andre emissivity means, yes, power to emit radiations. Absorptivity, power to absorb radiations for any black body is a constant and it is equal to unity. Andre E is the emissive power of the surface. How much radiations it can emit. A, absorptive power, how much radiations it can absorb. That ratio is always equal to 1, and this is called Kirchhoffs law of radiations. So dear students, today we learned what is convection, what is radiations, properties of thermal radiations, and Stephen's and Kirchhoffs laws. The next class we will do Newton's law of cooling, a very beautiful phenomenon. Until then, go through the previous sessions, come prepared. We will meet up in the next session. Thank you.